Okay, we continue for the next subtopic is namely as a recurrence relation. In mathematics and also in physics field, we have the recurrent relation for sequence. For sequence is an equation that will express the an is the term one or more of the previous term in the sequence. Okay, in sequence. Mainly, if you look at this one, AO is equivalent to AN minus 1. AN is previous current item. Okay, we calculate AN minus 1. So, N is greater than N null, where N null is a non-negative integer, whereby the AN is equivalent to N. Okay, untuk yang ni kita nak buktikan bahawa elemen selepas dia uh, adalah sama equal dengan elemen yang sebelumnya dengan kita gunakan we call it as a solution of recurrent relation. Yang mana kalau kita lihat kat sini AN is equivalent 3 AN minus 1 minus AN minus 2. This one is to satisfy the recurrent relation. Okay, nanti kita akan tengok. Sekarang ada soalan ke? Macam mana nak dapat 3AN minus 1 minus AN minus 2 lah. Ini based on the sequence. Sequence ni maksudnya kita ada nombor yang berjujukan lah. Jadi bila kita buat recurrent relation ni, kita akan tunjukkan bahawa nombor yang bukan negatif adalah sama in term of hubungan dia. Okay? Kita ada hubungan dia. Nanti saya akan tunjukkan lah macam mana kita nak buat calculation. Okay. Seterusnya, in other words, recurrent relation is likely is a recursive. Recursive maksudnya dia tengok nombor yang sebelumnya, but without specifying any initial value. Dia tak ada initial condition ni, dia tak ada lah. Okay. Nanti saya akan tunjuklah example. Therefore, the same recurrent relation can have and usually has a multiple solution. Kita ada beberapa penyelesaian masalah lah. Yang mana kalau kita lihat same recurrent relation ni, maksudnya kita ada condition yang sama lah. Kita akan tengok. If both initial condition and recurrent relation are specified, kalau kita dua-dua ni kita bagi tahu nilai dia, then the recurrent relation are specified, then the sequence is uniquely determined lah. Jadi sequence tu kita boleh tentukan dia punya relation adalah bersifat unik lah. Okay, for example, consider a recurrent relation. We have AN is equivalent to A n minus 1 minus A n minus 2 lah. Yang ni kita for n equal to 2, 3 and 4 and so on lah. Dot. Is the sequence AN with AN equal to 3n a solution of the recurrent relation? Ni soalan lah. Biasa dalam final exam dia akan tanya macam ni lah. So for n is greater or less equivalent to 2, we can find out or see that 2an minus 1 is minus an minus 2 is equivalent to, kita gantikan nilai tu. Okay. 2, 3n minus 1 minus 3n minus 2. So we have the solution is 3n. 3n is equivalent to an. Therefore, is a solution of the recurrence relation. Kalau dia sama, maksudnya dia akan ada solution lah. Ataupun dia call solving a recurrent relation. Yang ni kalau kita dapat buktikan, kita kadang-kadang kita namakan dia sebagai solving a recurrent relation, dapat menyelesaikan masalah recurrence ni. Okay, and then okay, this one is solution yang tadi tu, an to an minus 1 tu. Okay, kita buat in details lah. We have an equivalent to 2n an minus 1 minus an minus 2 lah. We have an equivalent to 3n is a solution. So we substitute 1 and 2 lah. Okay. So into a recurrent relation, so an is equivalent to 2 an minus 1 minus an minus 2 lah. Okay. Jadi an minus 1 is equivalent to 3n minus 3 lah. Okay, 3n minus 3. Okay. Minus 3n minus 6 lah. Kita gantikan dia. Kita darabkan dia dengan 3 lah. Okay. And then 6 n minus 6 is minus 3n plus 6 is 3n. Therefore, an is equivalent to 3n is a solution for recurrent relation an 2an minus 1 minus an minus 2 lah. Okay, yang ni kita dapat untuk substitute number 1. Yang ni kita dapat untuk substitute number 2 lah. Kita gantikan nilai n tu. Okay, 3n minus 2 kita akan dapat 3n minus 6 minus 2 lah. Okay, ini kita gantikan. Okay, kita gantikan dia. Kita gantikan untuk substitute number 1, this one substitute number 2 lah. Boleh ke? Yang ni kita gantikan dekat sini. Yang ni kita gantikan dekat sini. Yang ni kita gantikan dia dekat sini. Boleh ke? Slow je. Boleh. Okay, kita tengok another example. an to n minus 1 minus an minus 2, an with an equal to n. 2n is a solution for the recurrent relation given. Okay, sekarang ni kita dah ada an equivalent to 2n. Jadi kita gantikan je lah nilai dia tu. an minus 1 is equivalent to 2. Kita gantikan dengan n minus 1. Kita akan dapati 2n minus 2. Ini untuk substitute number 1 lah. Kita nak gantikan nilai dia. Lepas tu an minus 2 is equivalent to 2n minus 2. Jadi kita akan dapat 2n. Kita buka kurungan ni. 2n minus 4. Yang ni substitute number 2. So for the recurrence ni kita gantikan dengan nilai tadi tu. Yang satu ni. Jadi kita akan dapat an is equivalent to 2an minus 1 minus an minus 2. Yang atas ni is equivalent to 2n minus 2. Yang ni kita gantikan dia dengan minus 2n minus 4. So we have 4n minus 4 minus 2n plus 1. So negative and positive we have 0. So the an is equivalent to 2n is we call it as a solution, or we can call it as a solving a recurrence relation. Okay, another example. Saya bagikan contoh lain. Kalau tak faham, tolong tanya sebab yang ni penting untuk kamu punya final exam, final assessment. Okay, we have here an is equivalent to 2n plus 1 is a solution to the recurrent relation Tadi an is equivalent to 2an minus 1 minus by 1 with a1 is equivalent to 3 lah. So the solution dia macam mana? Siapa ada idea? Solution dia macam mana? Solution dia first is easy to check the initial condition. Okay, initial condition dia apa? Okay, initial condition is a 1. Okay, a1 should be 2 1 plus 1 according to our closed formula. Okay, and then this one is equivalent to 3 lah. Okay, yang ni 2 power of 1 is equivalent to 2 plus 1 lah. Okay, kita gantikan dia, and then to check that our proposed solution satisfy the recurrent relation, try and plug in into it. Dapat 2 a n minus 1 is equivalent to 2 2 n minus 1 plus 1 minus 1 is equivalent to 2n plus 2 minus 1 is equivalent to 2n plus 1. Okay, okay, this one is equivalent to an lah. Okay, so that we can say that this one is a recurrent relation sama dia punya nilai dia. Okay. Okay, and then kalau kita tengok another example, this one is recurrent relation, an equal to 1 is a solution of the same recurrent relation. Okay, 2an minus 1 minus an minus 2 is equivalent to 5. Okay. Okay, this one is the, okay, we have an minus is equivalent to 5, an is equivalent to 2n. So an minus 1 is substitute number 1. And minus 2 is substitute number 2 lah. Okay, so we replace an minus 1 is equivalent to 5, minus 5 is equivalent to 5 lah. It is a recurrent relation. Okay, so it is okay, this one an equivalent to 2n. Okay, an minus 1 is equivalent to 2n minus 1. Okay. Okay, this one initial condition. Initial condition for n 3n. We have 3, 6, 9, 12, 15, 18, and so on. Okay, an minus an is equivalent to 2n. It's 2, 4, 6, 8, 10, and so on. And an is equivalent to 5. Okay. So for the modeling recurrence relation, somehow we can see the deposit per year. For example, if you have the ASP, Amanah Simpanan Akaun Simpanan Bumi Putra ASP, we can save the deposit 10,000, for example. We have 10,000 in saving account at a bank yielding 5% per year with the interest compounded. Compounded maksudnya dia akan bertambah setiap tahun daripada pokok misal kata kita ada 100, dia akan tahun berikutnya dia akan tambah RM105. Okay, daripada yang ni, lepas tu dia akan tambah lagi 5% daripada yang ni lah. Berapa? Okay, ini kalau kita kira 105 105 tambah 110 kita akan jadi 100. 110, 50 sen. Okay. Dan seterusnya lah. Sehingga berapa tahun yang kita simpan lah. But the question in here is compounded annually. How much the money will be in the account after 30 years lah. Kalau kita ada 5% ni. 5% ni per year. Kalau monthly lagi banyak lah. Okay, the solution let PN denotes the amount of account after n years. How we can determine PN on the basis of the PN minus 1. So, modeling with the recurrent relation, we have PO. PO ni dia punya pokok. PO is 10,000. Annual interest is 0.05. After first year, P1 principal plus the interest. P0 plus 0.05 PO. And then we have 1.05 PO. Okay, and then after year 2, P1 plus 0.05 P1, and then this one is 1.05 multiplied by 1.05 uh, PO. Okay, and then PO plus PO is equivalent to 2 PO. Okay, after 3 years, P2 plus 0.05 P2. Okay, power of 3, and so on. So we can see this one is the pattern recurrence relation. We have 1, 2, 3, 4. After 30 years, we can have P30 is equivalent to 1.05 power of 30 is equivalent to berapa ni? Okay, kita akan dapat uh, apa? Kalau kita darabkan uh, okay, after 30 years, we have 43,000. Okay, 33,000. And then another example is assume that initial height of Mount Kinabalu is 4,095 meter. Due to the climate change, the sea level has increased nearly 0.1% than previous year. So approximate the highest amount of Kinabalu after 7 years. Okay, H new H0 lah. H0 ni dia punya ketinggian asal dia. And then the incremental of the sea. So we have first year H1 H0 minus 0.01. After 2 years, H2 H1 minus 0.01 H1. Yang ni kita akan dapat 0.999. Okay. After 7 years, H7 ni lah kita akan dapat, kita akan darabkan lah. 495, the answer will be here. Okay, so to solving the recurrent relation, in general, we should prefer to have an explicit formula to compute of an rather than conducting an iteration so many times. For one class recurrent relation, we can obtain such formula in systematic way. Kita ada formula yang khusus. Okay, we use the linear combination. Linear combination. Okay, and then this one is the constant coefficient. It's a recurrent relation. Okay, so we have this one recurrent relation of degree 1. This one is degree 2, and then this one is linear homogeneous recurrent relation of degree 5. Okay, homogeneous. Homogeneous maksudnya dia sama. Okay, and then this one is characteristic roots. Okay, okay. Tak ada apa, characteristic equation dia nak samakan dengan kosong. Okay, nanti kamu tengoklah yang ni, the answer for this one. You just see for this one. An is to 3 multiplied by 2n minus 2 multiplied by 3n. Okay, kita gantikan nilai dia. Okay. Okay, degree 2. We have the example for degree 2. Degree 2 yang dia tadi. Okay. Recurrent relation Fn is Fn minus 1, Fn minus 2 is homogeneous recurrent relation of degree 2. Okay, so far do you have any questions?